today we're going to talk about circular motion and gravity. And I'm going to try to carry this glass of, it looks like green tea. I'm going to try to carry it around without spilling it. And of course, you have to be very careful because, as you know, if you tip this, the water will come out. Oh. Do you know, what's strange about this is that the surface of the water is staying perfectly level with respect to the tray. It's not tipping. In fact, I hope this will work. I think I can do it even better. I can actually make it go upside down. Okay? So why doesn't the water fall out of the glass? And why does it stay so steady? Look, I can just walk around. I can be very careless. Wouldn't this be great in a restaurant? A waitress could carry water around and never have to worry about spilling it. Okay, let's have a look at why this happens. So, we're making the tray and the glass of water go around in a circle. And at the bottom, we have the water, and we have the tray. And this is, of course, attached by cord like that. So we're holding it up. Because what's happening here is that gravity is acting down with a force of mg. And that's holding the water in the cup, in the glass. When we start to swing it, let's say at this point, we're going with that velocity, call it v1, and then a little bit further on, it's going with this velocity, velocity v2. Well, what has happened to the change in velocity? What's happened to the velocity? It's changed. Well, when you change velocity, you have to push. The thing that's pushing or pulling here is the string. We're pulling on here, and this pull is causing the velocity to change. Well, when you change velocity, you also change acceleration. If we had the cup with water up here like this, and we let go, it would fall with an acceleration due to gravity. However, if we were in an elevator that was going down with the acceleration due to gravity, the cup would just kind of float, wouldn't it? And that's what's happening here. We're going fast enough so the pull on the string is making the velocity change by the amount of g. And if we go even faster, we can actually make, if we had, suppose we had someone in this cup, like a little person, upside down there, a little person in that cup, they would actually feel like they had gravity acting on them. In fact, an application of this is they could rotate a spaceship fast, and it would create the feeling of weight. This force, this pull, is called centripetal force. Don't make the mistake of saying there's a force going out. It's called centrifugal force. That's a fictitious force. It doesn't exist. So, if you want to try this, I suggest you try it outside.